Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss recursive in-order traversal of a binary tree in Java. So friends, what is in-order binary tree traversal? So here you can see that in-order binary tree traversal has basically 3 steps, and we apply these 3 steps to each and every node of the binary tree. So the basic steps involved in in-order binary tree traversal is we first visit the left subtree for a particular node, and then we visit the node, and after visiting that node we go to its right subtree. And these 3 steps we apply on each and every node of the binary tree. So let's take an example of the below binary tree. Now let's suppose we want to visit each and every node of this binary tree. So we start with the root. So here you can see root is pointing to node 1. Now we apply these 3 steps on the node 1. So here you can see basically the step 2 is involved in the processing of the node which we are currently pointing to. So here before processing the node 1, what we do, we first traverse its left subtree. So here you can see this is the complete left subtree which we want to traverse before we process this node. And after we process this complete left subtree, we then visit this node, and after visiting this node we go to its right subtree. So here when we are at node 1, then before processing this node we go to its left subtree. Now as we go to its left subtree we encounter the node 2. So when we encounter the node 2, we apply these 3 steps over the node 2, and before processing the node 2 we first traverse its left subtree, then we process the node, and then we go to its right subtree. So here before processing the node 2 we go to its left subtree first. So once we reach the node 4, we apply these 3 steps on the node 4. So before processing the node 4, we traverse to its left subtree, then we process the node, and then we go to its right subtree. So here you can see node 4 has no left subtree, therefore we are done with the processing of the left subtree. And after we are done with the processing of left subtree, we actually visit the node. So the first element we visit is the node 4, and after we are done with the node 4 we go to its right subtree, and we know that node 4 has no right subtree, therefore we are done with the processing of the node 4 completely. So the call returns back to the node 2, and from the node 2 perspective we have actually visited its complete left subtree. So now is the chance to visit the node 2. So we actually visit a node 2, and then we go to its right subtree. So when we reach to the node 5, we actually apply these 3 steps now on node 5. We traverse its left subtree, then we visit the node, and then we go to its right subtree. So here you can see node 5 has no left subtree, therefore we are done with the processing of the left subtree. So then we process the node 5, and after we process the node 5 we go to its right subtree, and we know that node 5 has no right subtree, therefore we are done with the processing of the node 5. So friends, after the node 5 is processed, the call returns back to the node 1, and from the node 1's perspective we have completely traversed the left subtree now. So now is the chance to visit the node 1. So we visit the node 1, and then we go to its right subtree. So once we reach to the node 3, we apply these 3 steps over the node 3. So before processing of the node 3, we first go to its left subtree, then we visit the node, and then we go to its right subtree. So when we reach to its left subtree, we encounter a node having data as 6. So we apply these 3 steps now over node 6. We visit its left subtree, then we process the node, and then we visit the right subtree. So here as node 6 has no left subtree, therefore we are done with the processing of the left subtree, and then we actually visit the node, and after visiting the node we go to its right subtree. And as node 6 has no right subtree, therefore we are done with the processing of the node 6 completely. Then our call goes back to the node 3, and we know that we have completely visited its left subtree. So now we can visit the node 3. So once we visit the node 3, the third step is involved is we go to its right subtree. So as we go to its right subtree, we encounter a node having data as 7. So on this node 7, we now apply these 3 steps. We first visit the left subtree of it, then we visit the node, and then we visit the right subtree. So friend, as we know that node 7 has no left subtree, therefore we are done with the processing of the left subtree for the node 7, and then we actually visit the node 7 and then we go to its right subtree. So here we can see node 7 has no right subtree, therefore we are done with the processing of the node 7. So here we have visited each and every node, and to each and every node we applied these 3 steps, that before processing the node we actually visited its complete left subtree, then we visited the node, and then we went to its right subtree. So friend, these are the steps involved in in-order binary tree traversal. Now let's go ahead and see the demonstration of the algorithm. So friends, let's suppose you want to traverse this binary tree where root is pointing to the node 9, whose left is pointing to node 2, and whose left is pointing to node 4. And node 4 has no left and right subtree, therefore they are pointing to null. Node 2 has no right subtree, therefore is pointing to null. And here node 9 right is pointing to the node 3, which have no left subtree and the right subtree. So friends, below you can see the algorithm for the in-order binary tree traversal. And here you can see the method name is in-order, which takes in a root. And in the method we are actually again calling the in-order method. Therefore these calls are recursive in nature. So in order to understand this recursion, we are using this call stack, where we are keeping the information for the current executing method, and we are also keeping the track of the root node which is getting executed in the particular method call, and we are also keeping the track of the line number, whose significance we will see once we demonstrate the algorithm. So let's see the demonstration of this algorithm step by step. Now when we call in-order method and we pass the root, so currently you see root is pointing to the node 9. So we know that this method will be part of our call stack. So it would look something like this, that now this method will be part of our call stack and this method will be executed with the root as 9, because currently root is pointing to 9. We move ahead and we check whether root is equal to null or not. So friends, why we are providing this condition, as this is the base case for our recursion, because in the in-order method we are again calling the in-order method recursively. So friends, in order to break this recursion we need to provide a base case, and if we don't provide this base case then this method will call each other recursively. So in order to stop this we are providing this base case. So currently you see root is pointing to the node 9, therefore it's not null. So the condition in if block comes out to be false. So in the first step what we do is, so what we discussed in the slide, that before processing of a node we will first traverse its left subtree. So we again call the in-order method, and this time we are passing roots left because we want to process the left subtree now. So here you can see root left is the node 2. Therefore this in-order method will call the in-order method again with the root as 2. So friends, here we are leaving this method and now we are entering to this method again. So we'll keep the track of the line number, that at the line 5 we left this method, so that once this method is processed we again return back to this method and we'll start executing from the line 5. So therefore we'll keep the information for the line number whenever we leave any particular method. So here we keep the track of the line number, which is 5, that we are leaving this in-order method at the line 5 and we are calling this in-order method again with a root 2. So friends, this method will be called again, and this time the root will be the node 2. So here now root, instead of pointing to 9, it will point to 2. And we also know that we have left this method in-order method, so there will be one more method on the stack. So now this in-order method will start executing with the root as 2. So let's see the working. We'll first check whether root is equal to null or not. So currently root is pointing to the node 2, therefore it's not null. So friends, as we discussed in the slide, before processing any node, we have to process its left subtree first. So in order to visit the node 2, we'll first have to visit its left subtree. So here we again call in-order method and we pass roots left. So here you can see root is pointing to the node 2 and we will call inOrder method and we'll pass the root.left, which is node 4. And as we are leaving this method, we will keep the track of the line number. So here now inOrder method will start executing with the root as 4. So currently root is pointing to the node 2. So now it will point to node 4. And here you can see there would be one more method coming on the stack. Now this inOrder method will start executing with the root as 4. Moving ahead, we'll check whether root is equal to null or not. So currently root is pointing to the node 4, therefore it's not null. And here before processing the node 4, we have to first process its left subtree. Therefore we are again calling the inOrder method. And we are passing root left. So currently root is pointing to the node 4. So now we are calling this inOrder method and we are passing the null value to it. And here we will keep the track of the line number. That as we are leaving this method and we are calling this method, so we are keeping the track of the line number. So friends, now inOrder method will be called again and this time the root will point to null. So here you can see currently root is pointing to 4, and as we discussed that we are going to root's left, so now root will point to null. And we also know that once this method gets start executing, there will be one more method on the call stack. Now here you can see this inOrder method has root as null. Moving ahead, we'll check whether root is equal to null or not. So currently you see root is equal to null. Therefore we have reached our base case, which makes sense because when we encounter a null value, it means there are no nodes to be traversed. So we simply return from this method. And once we return from this method, we know that this method will be removed from the call stack. And the execution point will go to the method which called this method. So now execution point reaches here. So friends, we know that at line 5 we left this method. So we'll start executing from the line 5 itself. So our execution point will now start from the line 5 because we have processed this information earlier. And we also know that when this method was getting executed, root was pointing to 4. So when step of execution reaches here, root will point to 4. Moving ahead. So friends, here you can see for the node 4 we have processed left subtree. Now is the time to process the actual node. So therefore we simply print root's data on the console. So on the output you can see 4 will be printed because root's data is 4. Moving ahead. And we also saw in the slide that after we process the node, we then go to its right subtree. So in order to go its right subtree, we again call the inOrder method and this time we pass root's right. So currently root is pointing to the node 4 and its right is pointing to null. Therefore we'll again call the inOrder method and we'll pass the null value to it. And here as we are leaving this method on the line 7, we'll keep the track of the line number. So now it will be 7. And we also know that once we call this method, so now inOrder method will be called again and this time with root's right, which is null. So friend, currently root is pointing to node 4 and when we call this inOrder method with a null value, therefore now root will point to null. And we also know that there will be one more method on this call stack with a root as null. So let's execute this method. In the first step, we'll check whether root is equal to null or not. So currently root is equal to null. Therefore the condition comes out to be true. And we'll simply return from this method. So once we return from this method, we know that this method will be removed from the call stack and the method which called it, the execution point will go there. So now the execution point reaches to this method And we also know that we left this method from the line number 7. So therefore the execution point will start from the line 7. And we also know that when we left this method, root was pointing to node 4. So therefore now root will point to node 4 again. And then we'll start executing from the line 7. So when we reach to line 8, we know that we have completely processed this in-order method. So therefore this method will be removed from the call stack. And the call will go to the method which had called this method. So now call will go to this in-order method. And we know that we had left this method from the line number 5. Therefore the execution point will start executing after the line 5. And we also know that when we are executing this in-order method, at that time root was pointing to node 2. So therefore now root will point to the node 2 and will start executing after line 5. So here we can see that before processing the node 2, we have completely visited its left subtree. So now is the time to process the node itself. Therefore we simply print its data on the console. So you can see 2 gets printed on the console. And after we process the node, we know that now we have to go to its right subtree. So we again call in-order method and we pass the root right value, which is null. And we also know that as we are calling this in-order method, we will update the line number here. So now the execution point reaches to this in-order method, and we know that there will be one more method on the call stack with a root as null. So here you can see root is pointing to node 2. So now this root will point to null. And we'll start executing this in-order method. So in the first step, we check whether root is equal to null. So here you can see root is equal to null. Therefore we'll simply return from this method. And we are returning from this method that because we have already processed its right subtree. So once we return from this method, we know that now this in-order method will be removed from the call stack completely. And now the execution point will reach to this in-order method. And we'll now start executing this in-order method from the line number 7. So we'll start executing from the line number 7, and as we know that when we were executing this in-order method, root was pointing to 2. So now root will point to 2. And then we'll simply execute this in-order method. So once we reach to the end of this method, we know that now this method will be removed from the call stack. And the execution point will reach here. So we'll start from the line number 5. And we also know that when we are executing this method, root was pointing to 9. So therefore now root will point to 9. And then we'll simply execute the steps. So friends, here you can see before we processed node 9, we completely traversed its left subtree. And after we traverse its left subtree completely, now we are visiting the node. So we are simply printing its data on the console. Moving ahead. And once we are done with the process of this node, we have to process its right subtree. So therefore we are again calling in-order method and we are passing the value roots right to it. So here you can see roots right is the node 3. And as we are calling this new method, we are updating the line number. So point of execution reaches to the in-order method with a root as 3. So now root is pointing to 3, and we also know that as this is a new method on the stack, there will be one entry on the call stack. So here now this in-order method will start executing with a root as 3. So we first check whether root is equal to null or not. So currently root is pointing to 3, therefore it's not null. And then for the root 3, we apply the in-order traversal again. We first visit its left subtree. So in order to visit its left subtree, we are calling inOrder method and we are passing root left value to it. So here you can see root left is pointing to null. Therefore we are calling this inOrder method with a value as null. And as we are leaving this method and we are calling this new method, we will update the line number. So then execution point will reach to this inOrder method with a root as null. So we know that there will be one more method on the call stack with a root as null. And now root will point to null. Moving ahead, we check whether root is equal to null or not. So currently root is equal to null. Therefore we'll simply return from this method and this method will be completely removed from the call stack. And as this method is removed from the call stack, the execution point reaches to this inOrder method, which actually called the inOrder method with a null value. And from which line we have to start? We have to start the execution from the line number 5. And we also know that when we were executing this inOrder method, root was pointing to 3. So now root will point to 3. So friends, now in this step, as we have processed the left subtree completely, then now we'll process the node itself. So we are simply printing the data on the console. And then as we have to process its right subtree now, so we are calling inOrder method and we are passing roots right, which is the null value. And before calling this new method, we are updating the line number. So when the point of execution reaches to inOrder method, root is null. So there will be one more method on the stack with a root as null. So now this root will point to null. And we'll start executing this method. So in the first step, we'll check whether root is equal to null or not. So currently root is equal to null. Therefore we'll simply return from this method. And when we return, we know that this method will be removed completely from the call stack. And the point of execution reaches here. So we know that we'll execute this method from the line number 7. And we also know that at that moment root was pointing to 3. So now root will point to node 3. And then we'll start executing from the line 7. So when we reach to the line 8, we know that we have completely executed this inOrder method. So this will be removed from the call stack. So friends, now the execution point reaches to this inOrder method. And we'll start executing from the line 7. And we also know that when we are executing this method, root was pointing to 9. Therefore we'll simply traverse root to 9. And then we simply process all the steps for this inOrder method. So now this will be removed from the stack. So friend, as we know, there are no methods left on this call stack. Therefore we have successfully executed the inOrder binary tree traversal. And the output you can see, it's 4293. So friend, this was a demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, I had created one class by name binary tree and I have implemented binary tree into that class. You can watch my previous tutorial in order to understand its working. So in this tutorial, we will simply write the code for inOrder binary tree traversal. So let's say I give the method name as public void inOrder. And as we discussed in the slide, this inOrder method takes in a root. Now in the first step we check if root is equal to null. Then we'll simply return from this method, because this is the base condition. As we are calling this inOrder method recursively, we have to provide a base case so that we can get exit from this recursion. And as we discussed in our slide that before visiting any node, we'll first visit its left subtree. So we'll call inorder method and we'll pass root left to it. And after we process its left subtree, we will visit the node. So we simply print root's data on the console, and in the last step we'll again call inorder method and we will process root's right subtree by calling root's right in the inorder method. So friends, this is the algorithm for the inorder binary tree traversal. Now let's test its working. Now in my previous tutorial I had created one binary tree, and this is the same tree which we discussed in the slide. Use this create binary tree method. So here in the main method we'll call create binary tree, and then we'll call the inorder method, and here we'll pass the root. Now if I run the code, so here you can see it printed 4293, which is the same output which we saw in the slide. So friends, in this tutorial we discussed the recursive way of inorder binary tree traversal. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.